Solving Quadratic Equations by Factorization Part 2. The second method for solving a quadratic equation by factorization consists of factorizing the left part of the equation so that the part containing the variable takes the form of one of the first two special algebraic identities. The rest must also fit this form, but in the first power. In other words, we must try to express the equation in the form we have the following shown on screen, where k equals square root of a while t and r are numbers. After doing this, we may make a new factorization in the form we have the following shown on screen. For example, the quadratic equation, we have the following shown on screen. We have the following shown on screen. This is because we can write the first three terms as x plus 1 squared. In this way, we obtain the following as shown on screen. Therefore, now we have a common factor to factorize. It is x plus 1. When writing this common factor separately, we have another x plus 1 left from the first term and 1 from the second term. Hence, factorizing this common factor yields, we obtain the following as shown on screen. We can make further operations in the square brackets to simplify the expression in it. Thus, we obtain the following as shown on screen. In this way, we obtained a factorization of the original equation that helps calculate the roots. As in the previous examples, when a quadratic equation is factorized, one of the brackets must be 0 to have a correct solution. Hence, in this example too, we have two distinct roots. One is obtained for x plus 1 is equal to 0, i.e. x to the power of 1 equals minus 1, and the other for x plus 2 is equal to 0, i.e. x2 squared equals minus 2. Example: solve the following quadratic equations by factorization. A. X squared minus 5x plus 4 is equal to 0. B. For x squared minus 10x plus 6 is equal to 0. Solution. A. We can try to factorize this equation by expressing it first in two ways. We have the following shown on screen. Or, we have the following shown on screen. The first disintegration is futile, it doesn't provide us with a factorization. As for the second disintegration, we have the following shown on screen. It is known that a negative sign before a pair of brackets makes all terms in the brackets change sign. The first brackets represent the expanded form of x minus 1 squared. As for the second pair of brackets, we can factorize 3 from them. In this way, we have the following shown on screen. Obviously, there is a new expression to factorize, x minus 1. Hence, we have the following shown on screen. Therefore, the two roots of the equation are as the following shown on screen. B. It is clear that to factorize this equation, we must have as coefficient before x squared a number that has an integer square root. Therefore, we have to express 4x squared as 2x. We have the following options available to express this quadratic equation. We have the following shown on screen. We have the following shown on screen. Only the first disintegration is useful in the sense that it can allow us to factorize further. We have the following shown on screen. Factorizing 4 in the first pairs of brackets and 2 in the second yields, we have the following shown on screen. The first pairs of brackets contain the expanded form of x minus 1 squared. Hence, we have the following shown on screen. Factorizing x minus 1 yields, we have the following shown on screen. Therefore, the two roots of this quadratic equation are shown in the following on screen. We have the following shown on screen. We could have used another approach to factorize this quadratic equation. Thus, we have the following shown on screen. That is all for lesson 9.5.3. To continue this tutorial, please watch 9.5.4, Solving a Quadratic Equation by Completing the Square. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.